Right now we have Daniel Cooper, who will be talking about how I fully compromised the most advanced code execution system in the world. Let's welcome him to the stage.
Hello. So I'll start with a quick introduction. I hate introductions, so it will be quick. So my name's Daniel Cooper. I'm currently a security consultant at Tanto Security, which is just like the last guy I know, which is why we have similar slides. However, mine are dark mode, so they're instantly better. No jokes. I love you, Ben. I also occasionally play on CTFs for teams such as Blitzkrieg and Emu Exploit under the username Sparrow. So that's enough about me. Today I want to tell you about a story. So, I have a friend who likes to develop things in his spare time. One of the things he is passionate about is competitive programming. So, one of the things that he wanted to do was make a contest management system. So for those that don't know, in competitive programming, you submit answers to problems which are just programs. They take in input through standard input and output the answer to the problem given the provided input, and they must do this in a time efficient manner so that you can prove that you've solved the problem efficiently. So once I saw that my friend had made this, I was like, do I really have anything better to do than spend time trying to hack my friend's apps? Then I realized the answer was no, so I decided to try and look into that and try and find out if there were any security flaws. So when I was looking into it, most of the app's source code was pretty secure, so I decided to look into some of the supply chain things, and in particular I wanted to see how my friend was executing this potentially malicious code on his services. The way he was doing that was through a sandbox called Judge Zero, and so I needed to look into how this works. Upon a few quick Googles, I found out that it is a fairly popular open source code execution API. As most people know, remote code execution as a service is generally not something you want to make, so it makes a lot of sense for software developers to outsource this to another application. In fact, Judge Zero is one of the most popular ones because of the fact it is open source, and you don't have to pay to use it. In fact, it even has a research paper written by the developer of how it is secure. However, I don't like reading research papers, so I didn't read it and instead looked at the code. Before we get into the code though, I'd like to talk a bit of a high-level overview of how the system works. It's pretty simple. It has an API. You send an API request with something like source code echo hi. It will run it. It will give you some output with such as standard output is hi, and some things such as the time it took. Pretty simple, except it's not, because there are around 80 languages and 30 different options, a lot of different complicated things that could potentially introduce security flaws. So it is quite an interesting target. So my plan of attack for trying to figure out issues with this system was to find out how Judge Zero runs the code that I provide it. I wanted to find out what prevents me from just spawning a reverse shell. I'm completely compromising the system. Can I read other submissions files and use that to cheat in a competitive programming contest, which might be used by more sites than just my friend's small website. So without further ado, let's dive into the code. So there are four main services. A Ruby on Rails server, as you can see in the top left, a database, a Redis queue, and a worker server. The way it works is first, the Ruby on Rails server will insert a submission into the database. Then it will add a job to process this submission into the Redis queue. The worker will read from the Redis queue once it sees a job that is added to the queue, and it will retrieve the job info from the database. Then it will process the job and update the database with the results of the job. Pretty simple. However, as I was looking through these services, which were in a Docker Compose file, I saw that it had enabled the privilege flag. This is immediately a bit of a red flag because having the privilege flag means that if I can get code execution inside the Docker container, it's pretty easy to escape onto the root machine that is running the Docker container. The reason is that privilege allows for access to certain files such as the device files for the disk of the host system. So you can mount the host disk system if you're a root inside the container, and then from there you can write malicious cron jobs, malicious scripts, or just dump all the data on the host system. So that was an initial red flag, but obviously we can't do anything with this unless we get remote code execution. So the goal became to get remote code execution inside one of these two services. By the way, when I say remote code execution, I'm referring to unsandboxed remote code execution. Sometimes I just want to make that clear. So looking through the code, I immediately see a massive string that appears to be evaluated inside Ruby backticks. This is not good. However, I got excited, but upon looking into it, it seems to be reasonably secure. I'll get into that a bit later. But the TLDR is that it seems to be using this isolate binary, which is a Linux binary, to run a submission. Isolate, when I searched it up, is a tool designed for competitive programming competitions, and it uses Linux namespaces to separate the different files and processes used by the system from the actual application's source code. So as I do not know anything about Linux sandboxing and Linux namespaces, I decided, hell no, I'm reading lots of C source code. I'm not that smart. I'm just a small peasant. But instead, I'm going to try and attack the Ruby source code instead, because that's something I can read. As a side note, one of the developers of the isolate binary did actually say that they don't support security of using isolate within Docker, which is what Judge Zero does do. So if you're smart at this sort of thing, maybe it is possible just to straight up break out of the sandbox. Beats me. Anyway, the plan is don't touch Linux. Instead, look at the flaws in the Ruby application. So I started scanning for a foothold. One of the things I did see was this weird G-sub. So what G-sub does is it replaces this regular expression on the left with the thing on the right, which is an empty string. So it seems to be removing some parts of a payload, and it's writing this to a bash script. And that's what the second line is with the file.open. So perhaps if I could bypass this blacklist, which was the characters $, ampersand, semicolon, normal bash special characters, I could get around this and potentially run my own code. So that's what I did. I looked at it for a while, and after a bit, I found out that if you use the new line character, it can actually execute on a separate line, which allows you to run a new process instead of the original line with the prefix, which was python3 script.py or whatever it was for the language that you chose. So that was a bypass for that, and I tried this on the remote one by setting the command line arguments flag to have a new line, and as you can see, it successfully runs the extra command separately as a separate process. So I'm like, yay, we've won, easy, remote code execution done, pwn the system. Except I read the source code and found out that the blacklist is literally pointless. It adds 0 things to security. So then it's like, no, it's over. We have to start from scratch again. The reason it's pointless is because it's writing to this script. However, this script is immediately run inside the isolate sandbox. So it's being blacklisted, but it's also running inside the sandbox. So what is the point of the blacklist? Because it basically has the same permission as your code in the first place. But this actually does come back later, so stay tuned for that. This failed. Another thing was, as I mentioned before, we have this command line that is essentially being sent straight into the system and being run in shell. So what if I inject into one of these parameters? Let's try it. A is not a number. Okay, well it seems like there's some sort of whitelist in this parameter. We can't directly inject shell characters and run a shell command outside of isolate. So what is exactly the whitelist? It seems like it has to be a number that is within some sort of range. So this didn't really seem like a potential way to get around this. It has to be numeric. It seems very strict validation. So this is a fail. At this point I'm like, okay, maybe this thing is secure after all. It looks like there are a lot of red flags, but maybe not. What about this line? We have sudo rm-rf boxster. That looks suspicious to say the least. In fact, one of my friends pointed out that if boxster happened to be an empty string, this would actually just remove every file in the file system. This is run outside the sandbox anyway. Boxster turns out to be some almost constant string, so this won't actually happen, but it's sort of fun to think about. So what if I could potentially replace some of these files? Because the sandbox allows me to edit some files within the sandbox, including this box directory thing. Could I replace it with a symbolic link? when this sudo rm-rf is run outside the sandbox, maybe this could delete some files on the host system, and potentially we could use this as an exploit primitive to do some other things. So I look at a bit into what boxster is. What happens is when isolate starts up, you give it this --init flag. It will give you this path, which is essentially a shared folder that will be used inside the sandbox. We'll go into more detail later, but boxster is just a box directory inside the shared sandbox. So I try replacing it. Turns out rm-rf doesn't follow symlinks, to probably no one's surprise, because then someone could like give you a zipped folder and then you unzip it and then it has a symlink to like the root directory. You delete it and then it deletes your root system. That would be bad. There might be a command line flag that enables following symlinks, but either way, Judge Zero did not do this. So I couldn't get this to work. Seems like that's a fail as well. But I managed to see something that I'm pretty sure could lead to something, which is this --share net flag inside of isolate. Judge Zero supports using this flag inside of isolate if you pass the enable network flag to Judge Zero in the API. Now, for those who've done a bit of security, this might scream server-side request forgery to you, and that's what it did to me as well. So let's try and see if we can contact some other internal services inside the Docker network. In fact, we have the PostgreSQL database and the Redis. The Redis is obviously a lot easier to target, but if we think about it, PostgreSQL actually has a lot more of the data in it, so maybe it'd be worth targeting that as well. Redis queue is essentially all it's doing is just telling the worker which jobs to run, so it's not that interesting unless we wanted to run a job twice or something. So I came up with a crazy idea. Before, when I pointed out this huge isolate string that we couldn't command inject to due to extremely strict validations, in fact, the data type of a lot of these were either string literals, which we can't change, or integers. What if we change one of the integers inside the database itself to be a string? Will the application crash? Hands up if you think the application will crash. No one, okay, well, some people. It doesn't. Ruby just doesn't care if you have well, the application didn't care that you are now changing this numerical value into a string. And as soon as it becomes a string, we can also just change it to have a command injection inside of it. So this works. So to summarize, what we have is the Ruby on Rails server which is running a job, and then the job contacts the PostgreSQL database, changes the data type of one of the safe integer parameters into a string with a command injection. Then once that job is executed, it causes a command injection and runs code outside of isolate. However, to actually create a proof of concept for this, I need to write a PostgreSQL communication wrapper. Normally you can just do import or pip install some PostgreSQL client thing, pretty easy, except I realized that we don't have libraries inside of Judge Zero. So what we do is we implement all of PostgreSQL from source, and I spent way too long on this, and it turns out there is some random documentation that is hidden on the dark web, or that of how you have to specifically MD5 hash the password twice and add in some like random value so that you can get the correct MD5 hash when password authenticating. And I want to, yeah, that's enough said about that. But after we get that working, which takes a while, we can simply just use $ and brackets to create a command injection, insert it into the database, and we're good. Here is the script. In case you haven't noticed, there is a for loop that runs the submit print high 20 times before and after the code. You may be wondering what this is for. The reason is we need to essentially trigger a race condition here. We need to have our code which causes the SSRF to occur run before another job has finished. The reason for this is that job needs to execute after the malicious one runs, and we can't modify another job that hasn't been created yet. So essentially we need to create a big queue of jobs that need to be run, and then we can run our malicious job while some other jobs haven't yet run. So that's what the number is. It needs to be increased if your system is good. 20 is fine for mine. However, you might be wondering, what is this PostgreSQL password? Well, it seems safe because password cannot be blank. Only used in production. It has no default. You must set your password, except the default is your password here. And I can guarantee you 99% of users do not change it from your password here, 1, 2, 3, 4. Because nowhere in the setup guide does it tell you to change this, and most people don't read through every option in the configuration file, which is where this is. So this would guaranteed work on most people who haven't changed this password, which would be most of the users of Jet0. So the three things we need for this to work are we need the PostgreSQL password. This will probably just be your password here, 1234. We need enable network to be true, but it turns out there's another flag that we need, which is inside the configuration file, the same one with the PostgreSQL password, which is we need allow network to be true. With allow network false, the enable network feature is disabled. And it turns out this is actually disabled on the publicly available one, which is sad because otherwise I could pwn the publicly available one. No, I would never do that, I'm joking. So this is good. We have a vulnerability that works with three conditions. However, if we want to increase our CVSS score, we need it to work with no attack constraints. So let's find a better one. So back looking at Symlinks again, we have another similar RM thing. Before I talked about Symlinks with RM-RF. RM-RF does not follow Symlinks, seems like a fail. However, what about this chown? So chown changes the owner of a file. It turns out that it does behave a bit differently. So if you see here we have a file and a symlink to the file. If we remove the symlink, it removes the symlink. But if we do the same thing with changing the owner, it actually changes the owner of the file instead of the symlink. This is quite interesting, especially since if you add the recursive flag, it actually changes the owner of the symlink, which is sort of the opposite of what you'd expect, which caused me a huge headache when creating these slides because I accidentally used the R flag and then was wondering why they patched my exploit. But I don't want to talk about it. So can we change the owner of arbitrary files using this? What we could do is, if we look back at the code again, if we change the run script, which is another file inside the shared folder, to be a symlink to a file on the host machine, when this line is run, which will be run outside the sandbox, it should change the owner of our symlink and follow the symlink and change the owner of any file we want on the host machine. So that's what we tried. And it worked. And I was like, this is great because what we can do is change the owner of our root owned file to our current user, which is run as a low privilege user. However, what I didn't realize was that a low privilege user was only used in the development environment. In production, everything is run as root, which is counterintuitive again, but who knows. The problem with everything running as root is root can access everything, so it doesn't matter. We can't denial of service by changing the owner of a file. And also, we're changing the owner from root to root because everything's just owned by root. So it essentially does nothing. So this seems like a fail as well. Oh well. Moving on. But as I was doing this and looking for ways that changing the owner of a file could change, could follow symlinks, I was like, wait a second. Maybe Ruby file.open follows symlinks. Of course Ruby file.open opens symlinks. It is just opening a file which would follow a symlink. And in fact, we have file.open right here in this file.open run script, the same thing that I was staring at ages ago when I was trying to find a bypass for the gsub blacklist. So what if we replace this run script with a symlink? Will it write to any file on the file system at the time of this running? So I realize I've been talking a lot about symlink inside sandbox, something or other, very complicated. So that's a lot to take in. So what I've done is I've made an animation which can actually help us visualize, and hopefully this works. Let's find out if it works. So I'm going to step through this a bit. This is the normal workflow. So this will represent the Ruby API server. This is the isolate binary, which is stored at the path user local bin isolate on the host. So what we do is we first run isolate with the init flag. This will set up our shared folder. This will create two subdirectories inside the shared folder. One will be called box and one will be called temp. Sorry, to clarify, these two folders will be created by the Ruby process itself, but they're not too important for our cases. Then Ruby will create the submission file inside the shared folder. So in this example, we're going to be talking about a C workflow, so we can just see what compiling the source code actually looks like as well. So we're going to be creating a file called main.c here. And we'll be compiling this. So to do that, Ruby will create another file called compile.sh in the same directory, in the box directory. It will contain something like gcc compile args main.c. Just have this. So now, as we know, compiling things can sometimes have side effects, so it's good to enable the sandbox before doing that. Judge 0 follows this. So we'll enable the sandbox and run the compile script, which produces the compile binary a.out. Now what we're going to do is disable the sandbox again. We'll create a run script, which we'll call run.sh, and it will essentially have a.out plus any user supplied command line arguments, which is the thing that is gsubbed as we talked about before with the blacklist. Then we are ready to finally run our program, so this will be the point where the timing starts. We'll enable the sandbox. We will run the run.sh script, and it will produce the output. And also we'll be able to time how long that took. After this sandbox is disabled and we change the owner and remove it. Remember, this is where our changing the owner vulnerability occurred, because we're changing the owner of run.sh, which could be changed by the application as it is in the controlled sandbox to point to somewhere else. So that will clean that up. Then some other stuff happens, but it's not really too important. So hopefully that clears up what is happening. So what happens if, as an attacker, we replace run.sh? So we'll go through the first part again. Everything gets set up. We write the source file as previously, except this time we use new line injection. New line injection with the gsub. The gsub blacklist is also applied to the compiler arguments, which are inserted here. So we can use this to insert a new line, add a comment at the end, and add in some malicious code. So our code will be to create a symlink called run.sh, which points to user local bin isolate. Now we'll compile the file, but what it's just doing is running compile.sh, which creates our symlink as mentioned earlier. This happens inside the sandbox. Now Ruby will try and do the same thing it did before, which is writing the run script to run.sh, except this time it already exists. Ruby doesn't expect this. It still opens it as usual and writes to it. But this is a symlink, and as the sandbox isn't enabled, it will evaluate it and overwrite user local bin isolate. So through this method, this file will be written to user local bin isolate. Now if we were to create another submission at this point, it would call user local bin isolate as it did at the start, except this time it is replaced with our script, which we specified here-ish. Where is it? a.out, and we have another new line injection in the script which runs some malicious code. So that's how we can get our reverse shell. So that's how we can get code execution, and we essentially all we need to do is just control command line and compile time arguments. To actually get the final step, we just need to change these command line arguments supplied, which will be, in this case I put in curl host.docker.internal just to connect to my listener to see if it worked, and it works. If we want to run a more complex payload, remember the command line arguments are essentially where our payload goes. We need to bypass the blacklist if we want to run a more complex thing such as a reverse shell, which might have some of these bad characters. It turns out a lot of characters are still not applied to the blacklist. So if we run python3-c underscore import os.system, that is completely fine by the blacklist. And then I can add bytes.from hex to hex decode something, and that will allow me to execute any system command. The command I want to execute will be encoded in hex, which is all allowed characters. So now I can completely be free to run whatever code I want on the Docker container. And from there it's trivial to mount the host disk and achieve execution on the host itself. The attack surface of this is quite large. This is the Judge 0 IDE, which is just a publicly available website. You can just go like ide.judge0.com. You can change the command line arguments and the compile time arguments here. So because it lets you change it, you could pwn this system just by doing this. It's patched now, so don't try it. Or you can if you want, I guess. So this is obviously quite bad. I decided at this point I need to report this. However, what if the author of Judge Zero just decides, okay, this person added in a couple of new lines and managed to exploit my system? What if I just add a new line to the gsub thing and then fix it? This isn't the root cause. The root cause is that we are writing to a symlink. So I thought it would be better if I made an exploit that worked without abusing the new line primitive, the new line exploit. Then I could report the issue separately. So to create an exploit that doesn't require the new line, we use it twice. We used it once in the compile time arguments. We used it once in the command line arguments. Both of these need to be handled separately. So for the first one, compiling, the reason we had it was so that we could create a symlink that would be written to when the run.sh happens. However, it doesn't need to be created at the compilation stage. It just has to be created before the run.sh file is written. And it turns out there's another stage that I'd been neglecting up to this point, which was that Judge Zero allows you to upload a zip file. Initially I was thinking, oh, zip slip, we can just put .. inside the zip file entry and overwrite an arbitrary file on the host. This doesn't work because the zip file unzip is run inside the sandbox as well, which is good. However, we can still put symlinks inside of zip files. If you don't know that, then now you do. So what we'll do is we'll just create a zip file and upload it and put user local bin isolate as the path in our zip file. So it will essentially achieve the same result of creating a run.sh symlink without using the new line injection, the compile time arguments. Now that's sorted, we need to find a way to do it with the command line arguments. Maybe we could add something like -c in Python, which just executes the supplied Python code. And that would be able to execute our shell code. Or our command, sorry. But it turns out that most programming languages which use interpreters, which would allow this, actually treat this as arguments to the interpreted program unless you put this command before the thing itself. So for example, here we have python 3-c print pwn script.py. That works because -c is beforehand. But if we put it afterwards, -c is passed into the script itself and it doesn't work. I couldn't find a language that easily allows you to get around this. As a side note, you might be wondering, we control script.py, right? Why can't we just put our reverse shell in script.py? The reason is we override user local bin isolate. And when it is executed, our current working directory is different. So script.py will actually not load the correct script and we can't really control what script it loads. So that line's always going to fail. The reason that the new line worked originally was because bash doesn't stop executing if a command fails. So even though python 3 script.py or whatever command ran in the wrong working directory, it failed. Our next line with the new line injection would still work. However, as I looked through the list of languages, which is massive, I found this, that SQLite was there, which go figure, imagine writing a competitive programming solution in SQL. Some people are built different. So anyway, SQL has this flag called -cmd and what its label is run command before reading standard input. And if you see up here, this run command is to cat the script and then pipe it into SQLite with a database. So what's actually going to happen is this isn't going to work because script.sql isn't going to be the correct working directory. But because this command runs before reading standard input, it actually doesn't care that it's receiving 0 standard input and is going to error out. So this works perfectly. We can add -cmd at the end and it will execute some SQL commands, which doesn't seem like much, without using the new line injection outside of the sandbox. And SQL conveniently has this way to execute system shells from SQL. Why did they add that? I don't know. And it's just .shell and then your command. So here's the final exploit which just puts all this together, creates the zip file with the symlink in it, and it creates the Python encoded payload, and it uses SQLite to execute without when running the user local bin isolate, which gets overridden. So I'm going to give a live demo. It's going to go wrong, but I have a video backup, so it's all good. So here is my terminal. So the first thing I'm going to do is show you what the first script is. So this is just going to start Judge Zero version 1.13.0. So let's do that. While that's going, I have two other things. Wow, this is zoomed out. So this is just a normal netcat listen on port 9001. And so we'll start that listening. And the other script is the exploit that I just showed above in the slides, which is just create the zip file and execute it. This time I've replaced my payload with a simple bash reverse shell. So if we run this, it should go choo choo choo, and then we get a reverse shell connection inside the Docker container as root. Thank you, thank you. So we're not done yet, because if we ls the dev and we, oops, this terminal is cooked. This is actually my host hard disk. So, should I try and demo this? Yeah, why not? So if I create a mount point, and then I mount, sure, why not this, into ASD, this is my Windows partition, lol. I didn't expect this to happen. But as you can see, I can read data on the host of the machine, which is completely bypassing the normal safety guarantees that you get from using Docker. So we managed to completely, if someone was running Judge Zero and a heap of other stuff, we'd compromise all of it. We'd get root access on the remote machine by just writing a cron job or a script. Okay, live demo worked, yay. So, back into reporting. So, they didn't have a vulnerability reporting process at the time that I found this, but the guy who develops Judge Zero, this guy, is a really nice guy, and it was actually pretty seamless, even though there wasn't already one set up. So I'll walk you through how it went. Firstly, I sent an email to contact@judgezero.com and said, hi, I found a security issue, where can I report this? And he responded pretty much like an hour later. Oh, sorry, yes, an hour later. And asked me to reply. However, Gmail thought it was a good idea to send this reply to spam, so I never realized I had it. Another thing I tried was sending a message over Discord, and he replied on there too, and luckily Discord doesn't send messages to spam, so I was able to send him my proof of concept. At this point, he started panicking, and he sent me an email asking if I'd compromised his services, which I hadn't, luckily. And after I'd explained it all, he got me to walk through the vulnerability, he created a fix for it, and organized a call. So this was pretty much one of the fastest turnarounds. Well, I mean, there have been faster, but it was really good. And we did have the call, although it wasn't at midnight, which this one was. He lives on the other side of the world, so it's a bit awkward. But the way we wanted to go through and get CVEs for this is GitHub has this security page, which you may or may not know about. If you go there and it doesn't have a security policy and you're the owner of the repo, you can set up a security policy. And then you can allow people to submit things, advisories, then you can approve them, and you can request a CVE through GitHub, which is really nice because you don't have to go fill out that form that is really old. So I got 2 CVEs for the SSRF and the sandbox escape. However, we aren't done yet because we need to look at what the actual fixes were for these issues. So let's see the commit history. Create security.md. Yep, seems about right. Update version, seems about right. Use user Judge Zero. So I was a bit confused by this because I expected something more along the lines of prevent system from using symlinks when using Ruby file to open. A bit verbose, I know, but still. Anyway, I get onto the system and all I find out is that the user that Ruby is being run at is now Judge Zero user. It is no longer root, it is a low privilege user, which means that we cannot no longer overwrite user local bin isolate because our arbitrary file write is now only limited to files that we have permission to overwrite as the Ruby process. However, if you have a keen eye, you may have noticed that one of these folders is not owned by root and is also owned by the same user that we are running at, which is Judge Zero. It's this one here. It's the temp folder inside the API root directory. So what's inside this folder? I decided to take a look. Looks like there's a few interesting things. Cache environment PIDs restart.txt. I grep for some of these keywords inside the source code, and I find out that environment is being run as a bash script every 12 minutes. So essentially all I have to do to fix my exploit is overwrite this script instead, and every 12 minutes it will be run. That's what I thought, except it turns out that Herman had accidentally broke the cron tab when he changed to the user judge 0 because cron tab needs to be started as root. So I asked him to fix that so that I could get my vulnerability to work, but I'm just joking, I told him about the vulnerability as well and he fixed that very quickly as well, which I'm very appreciative of. And here's the commit. However, up until this point I've been relying on all the different things as I get more knowledge of Judge Zero's internal source code to chain together different tricks that can be used to do it. And there's one thing that I figured out before that I thought had no impact, but now very realistically has impact. And if you can guess it, then good job. I'm not going to let you try though. It was the change owner vulnerability. So if you remember, this vulnerability allowed me to change the owner of any file to the current user. However, it was useless because everything was run as root. However, no longer are everything run as root. Now things are run as judge 0, which means we effectively have a primitive which allows me, whoopsie, to change any file to our current user, which we can then overwrite again. So if we, I love my little animation, so we'll show another animation. If it decides to load though. Okay, so first part is all the same again. Choo choo choo. Up until the end where we remove the symlink. So the compiled binary this time contains some code which replaces run.sh while it is being run. And now it replaces it with a symlink to use a local bin isolate. Now, as mentioned before, we're going to change the owner of the symlink and remove it as a cleanup step. This time what it's going to do is change the owner of the symlink, but instead change the owner of use local bin isolate. And now if we run the entire exploit, the previous one all over again, isolate is now owned by our current user, so it's completely fine for us to change the data inside of it to a reverse shell payload. Also, I believe the judge 0 user has plenty of ways to get to root, so it's not a problem for mounting the host disk again. So once I submitted that, that was another CV and it was fixed as well. As a side note, the way it was fixed was just changing more files to be owned by root. I did speak to Herman because I believe that changing the way that the symlinks are handled in the source code would be a better way of fixing this, but he said that it's better to just patch it like this because the source code has been left for a while and will probably break if he changes too much stuff, which I think he found out the hard way of the cron tab. Anyway, so future research points. So I moved on to other things now, but sometimes I do think about where I would go if I came back to this. So this exploit is quite nice in that probably a lot of people didn't update their judge 0, so it would probably still have impact in the real world for a lot of interview platforms and things like that that use judge 0. However, a lot of platforms such as this, all they do is they let you edit the code that you're submitting to the platform. They don't let you change the command line arguments or the compile arguments or upload a zip file as we used to upload the symlink without a new line injection. So I was wondering if there was a way for me to exploit this only by changing the source code, the exact same vulnerability. So what we'd need to do is create a symlink at compile time so that we can create run.sh that points to user local bin isolate. I looked at some languages that allow you to do things while it compiles. So Rust allows you to run like procedural macros while it's compiling, but it turns out that you need another compiled binary for the procedural macro to compile correctly, and I'd need a multi-file project to do that, and then we've come full circle because we need to supply a zip file again. Even if we were able to create a side effect, oh wait, one more thing I did try was there was a thing called CVRS, which some of you might have heard of, that lets you do buffer overflows and stuff in Rust. I tried to get this to work, but it seemed like most of the available proof of concepts were simply using the runtime of the Rust thing to cause the buffer overflow, and I needed this to happen when the binary is compiled. So I wasn't able to get that to work either, but if you're a big Rust nerd, maybe you could do that. I know you're out there. So we also, even if we were able to create this symlink, the thing that we're written, the only part that we control is the command line arguments. And this is directly taken from the JSON fields of the request. So I couldn't really think of an easy way to manipulate the output of the file to get code execution. There are a lot of languages, and each language does have these different things that it will write at the start, like Python 3 script.py for Python, for example. But it doesn't seem very feasible at all. Yeah, I have finished extremely early. Whoops, talked too fast, but questions?
Do we have any questions in the audience?
Not sure if you're the right person to ask, but from the blue side of things, for platforms that providing application runtime, what would be the good practices to mitigate this kind of attacks, or maybe spot them?
Yep, so I believe the question was, if I was with these types of code execution systems, how would I mitigate these problems? So I believe the problem with this program wasn't to do with isolate. I think that the isolate was mostly sound, apart from the disclaimer that I said about using Docker with isolate. The main issue was that it was sort of turning the sandbox on and off again and doing all the different bits in between. What would be good is if it didn't really ever touch the sandbox from the Ruby code after it had set it up and torn it down, because then there's no chance for you to sort of change things in between and add symlinks and stuff like that. And also, when removing it, making sure not to deal with these symlinks, because most of the vulnerabilities were just directly to do with the use of symlinks inside these things. So if, for example, it was set up the sandbox and wrote compile.sh and run.sh immediately, then we would never be writing to these files. So we wouldn't be able to change it to a symlink because none of the user supplied code hasn't run yet. But when we do run it, if it's changed, it doesn't really matter because it's already inside the sandbox. Yeah, cool.
Are there any other questions? One at the front over here.
Hello, lovely talk. So when you got downgraded to Judge 0, so you're unprivileged, so you go back to use the chown to like be able to modify isolate. Isn't it like chown and RM? So does the like RM, does that remove isolate and does that cause any issues, or am I just misunderstanding what happens there?
That is a good question.
Thank you.
I'm actually not sure why that happened because I just did it and it works. So I think it might be to do with the owner of the directory still being root. It might not be possible to remove the file, but I feel like it should still be able to remove the file. I did sort of simplify things a bit here though. I didn't actually target isolate because targeting isolate and changing the owner of isolate actually causes the application to crash in such a way that it never executes isolate. It's to do with because of the fact isolate was set UID and needed to do something. So I ended up targeting the remove binary, like the standard Linux remove binary. And I think, oh yeah, that's actually why it worked, because I replaced the remove binary. It wouldn't actually run remove, it would actually just execute my payload. So yeah, that's the answer, and I just figured that out just then. But that wasn't on purpose either.
If there are no other questions, let's thank Daniel one more time.